excited about the event today, our webcast. Old colleague Cedric. Cedric, why don't you quickly introduce yourself to the folks here?
Yeah,
what
sure.
you work on?
Yeah, so I kind of know Gradle a bit. Like, I used to work for Gradle. I actually joined Oracle a year ago to work on Micronaut, and I'm basically specialized in tooling for years now. So I used to work for Gradle, but before that, I was actually working for Pivotal on the Groovy language. So I've been in tooling for quite a long time, at Oracle right now, I'm mostly focused on Micronaut, but build tooling around Micronaut and developer productivity mostly. So right into the topic for today.
Perfect. And Sergio, why don't you introduce yourself as well and what you do with the Micronaut project?
Sure, I am the Micronaut lead engineer at a company called Object Computing, who is the company behind Micronaut since its inception. Been involved in the framework since it started back in 2018. Been working on open source before then, also in another framework called Grails. So Graham Roche, Micronaut founder, and many of the people behind Micronaut, James Clee, they were all like working on Grails before that. So that's kind of Micronaut is like the second book of the Micronaut saga, of the framework saga. So yeah, involved in open source for a while. Also with a lot of experience with Gradle as a user. Grails uses, starting from Grails 3, uses Gradle as the build tool. So was using Gradle as a Grails user, and yeah, quite a big user of Gradle.
And as we'll talk about today, the Micronaut project uses a lot of Gradle, but Build Tool is not specifically why we're here today. We're here to just chat about developer productivity and the journey that the Micronaut project took to improving developer productivity for all the developers, internal and external, that work on that project. And that's what we're here for. And that's what Justin and I here at Gradle have been doing heavily for the last couple of years, really promoting productivity engineering, why it's important. Many of you are doing it today, but how you should do it with data and have a dedicated team and sharing some of those best practices and lessons learned. And with that, we'll segue into our topic for today. And Sergio, why don't you tell us a little bit about the Micronaut project? What is it? What's the software and tooling stack?
So Micronaut framework is a JVM framework. It allows developers to build almost any kind of application with either Java Kotlin or Groovy, and they can build from CLI applications to monoliths to microservices to serverless functions that can be deployed to things such as Lambda or Azure functions. The framework did kind of goes in a different approach from traditional frameworks, where we do most of, we like to say, like, we want like smart compilers and not so smart runtimes. So we kind of move a lot of the logic that you will typically do on runtime to build time. So we give users dependency injection, configuration injection, validation. We have like a project called Micronaut Data, which is kind of a persistent solution where we implement most of that logic that traditionally was being done on runtime. We do that on build time. And that has a benefit for users in the sense that Micronaut applications, they are really fast to start up. They consume less memory. They don't use any reflection. So we are like a match-making heaven for GraalVM. So it's kind of a new take of how to build modern Java applications. But yeah, we like to say Micronaut is a foundation tech framework. You can build anything you want, and that's what we see. We have many people using Micronaut for everything you can imagine, from gRPC projects to traditional monoliths.
What's the software stack behind the Micronaut Foundation? Either Sergio or Cedric, whoever wants to take that one.
Let me take it. So one thing I forgot to say is, so Micronaut is open source. So Micronaut is open source and the Apache 2 license. So Micronaut is, we write most of the code. I would say 99% of the code is written in Java, code that goes, that we distribute, and we test it with Groovy using Spock as a testing framework. And we build the project with Gradle. We have done that from the beginning. And that's kind of the software stack. Then we host the project in GitHub. We have a GitHub organization. And one of the things that we did almost from the beginning is we are starting modularizing the framework into multiple repositories. So you have quite a core repository, but then we have many, many repos. I think we have more than 50 modules. There are some modules that have been there and now they're archived. So there is like already the framework is going to be, we're going to release Micronaut 4 by the end of the year. So it's kind of a new framework, but it's already like mature enough and it's in production for many companies. But that's kind of our stack. So Java, Spock with Groovy, and Gradle to build it. We use GitHub Actions as our continuous integration server. And we released our artifacts to Maven Central and also to a wonderful tool called SDK Man. We distribute like a CLI application that users can install in their machines. And that's more or less the story.
Well, that's great. And I think that's some of the stuff that the audience here would be really interested in, to know what's actually happening underneath the hood. So thanks for sharing that. And as far as developer productivity and what led you all here, right? I recall our first chat with both of you, right? He said you had all these challenges that you needed to modernize the Micronaut framework builds and tests and how it was. What were some of those challenges that for you guys said, okay, we really have to do something about this. It's really hurting us. And also, how was it hurting you, right?
Yeah, let me explain the problems, and probably Cedric can explain the solutions better than me. So you have probably heard that there are some organizations that use like a mono repo or a multi-repo culture, and we went to the multi-repo, and it has definitely some advantages, many advantages. So it allows like to have different individuals taking care of a repo with one of the challenges working in open source is just catching up with notifications. So having like different compartments where you can like focus a few code that you can work is definitely beneficial. But what we saw is that, so the team behind Micronaut is fully remote, is from many companies. So Cedric is working in Oracle Labs, working at Object Computing, is distributed throughout the world. So Cedric is in France, I'm in Spain, people in the States, we have people in India. So we have, and plus we have community all over the world, right? So there is like activity across countries, across time zones. And even if the core team is quite small, what we saw is that when we started like creating new modules, some of those modules have slightly different builds depending on the person who authored those builds, right? And one of the problems that we saw is that it was really difficult for us to like keep the build in sync. And it was key for us, right? Because we needed like so being a small team, as much as we can automate and as easy as it is. So there are two things. One is upgrade automation, right? So we want to be able to like upgrade modules to the latest, build good practices as fast as we can. And another one is consistency, which I think is great for us in terms of developer productivity, the ability to jump into a module that you never touch and be comfortable with the build. Know that the build is identical to the other modules, while giving flexibility for people to have like custom build logic. So we have some modules that they have special requirements. I don't know, like we have a MyCode Kotlin module, which needs other things that other modules they don't need, or MyCode data. So we have these three legs, essentially, like consistency, kind of automation of upgrades, and the last one is give flexibility. So don't be like a constrained environment. And I think Cedric can probably talk more about the solution, because he was the one who drove most of that improvement. So
yeah, sure. So I can give you more details, juicy details. So basically, when I joined a year ago, the project work already had started to fix those issues. But basically, the biggest problem that we saw back then was those 60 repositories or more. Like actually, I checked yesterday, and there are more than 100 repositories and 60 active. So it's quite huge. And you can imagine that whenever you have a Micronaut release, then you have some coordination to make, like what is actually a Micronaut release? Like what does it consist of? So it's basically bound to the lifecycle of the Micronaut core project. So when we release a new version of Micronaut, what you have is an artifact, which is Micronaut core, but actually what it does is referencing all those different projects which are in different repositories, and you have all those different releases. They have their own lifecycle, etc., etc. So coordinating that is a huge work, which is done actually via GitHub Actions mostly. Like every time you have a release of a module, it's actually pretty simple to do a release. Like I was astonished when I joined the project to see that you could just go on a GitHub page, GitHub release page, edit the release notes, click on publish, and everything was automated. So it was building a project, testing it, pushing on Maven Central, and then you got pull requests to actually push everything to Micronaut core so that it upgrades the versions for all the different modules. So this is already one kind of automation, but this is not really the one that I was mostly involved in. The one that I took care of is really this aspect that Sergio mentioned, which is how to minimize basically the maintenance of all those builds. So the idea is really you have 60 projects, let's say 60 projects, and all of them should be built the same way as much as possible. And because of the history of Micronaut, all those projects were using build scripts which were inherited from Grails back then, which was using a very old version of Gradle, like it was an early adopter of Gradle already. So it was using all kind of old practices which are not yet, well, they're not really Gradle idiomatic for today, you know. And because of that, it was actually difficult to put all those new idiomatic patterns at play so that it works properly. It was difficult to actually introduce new features, like say we want to have a Gradle Enterprise build cache. So how do we do that on 60 repositories, etc.? So a big chunk of the work was actually to streamline that. And to do that, we have what we call internal build plugins, which we use now. So if you go to GitHub, our organization, there's a special repository which is called Micronaut Build. And this is purely internal plugins, like purely Gradle internal plugins. And those plugins actually have all the common logic of all those different projects. And the idea was to migrate as much as we can from all those build scripts to those shared plugins so that you don't have to repeat how you build, I don't know, a guide. You don't have to say how you're going to configure check style. You don't have to say how you're going to publish to Maven Central. Or you don't have to explain how this module is going to publish a bomb, because everything is standardized. So the idea is really to have custom conventions that we create in those plugins, and then you have a small DSL in every project if you need customizations. So the biggest work really for me was to actually migrate those old builds to the new pattern, and maybe to make that a bit more concrete, I can share a couple examples of what we had to do. So
yeah, absolutely. And so just to recap, right? Yeah. You have many developers all over the world. You have 60 source repositories with all these legacy build scripts, old versions of Gradle. By the way, side note, how old are we talking about? Are we pre-1?
No,
it's
actually a good point. So we're talking about old versions of Gradle, but the build scripts were designed for old versions of Gradle, right? But Micronaut itself is always on the edge. Like, we're using the latest Gradle always. Like, as soon as there's a new version of Gradle, we migrate to the latest. So so we don't have the upgrade problem, basically. Like, we keep in sync, so it's not really a problem. But the problem was really that those build scripts were not using the patterns, the modern patterns.
Got it. And so you created these conventional plugins to templatize and automate as much as possible to take the burden off these developers that are contributing to this open source project and make it easier for them, essentially, right? And help make them more productive in a way. So this way you can kind of, as you said, like roll out the Gradle Enterprise build cache to everything without having to do it one by one in a single source repository. That's pretty cool. Tell us a little bit more about, or give those examples.
Yeah, so maybe some people in the call are actually more familiar with Maven, but if I can say a word about what convention plugins are, you can think of that as a parent POM, but instead of having just a single parent POM, you can have many. Like, you can do composition. So that's the key aspect why we use Gradle rather than Maven for that. So it allows us to compose different aspects. So some examples. To do that migration. So one of the goals was typically to reduce the build time, because we want to be as fast as possible, of course. So to do that, we wanted to leverage the build cache. So how do you deploy the build cache on 60 different projects? How do you make sure that this project is not broken because it does something bad? So initially, the state of the build was typically the guides were built in every project, and if you did Gradle docs, it was actually building the guides. But if you did Gradle docs again without touching anything, it was re-executing everything. And that was because basically you had many tasks which were overriding the outputs of each other, etc., etc. So the initial step was really to get rid of all those bad patterns and make that incremental. And to do that and to make the migration possible, it was absolutely necessary for us to integrate with build scans, right? So the first really step was actually to deploy build scans on all those projects. So the initial work was actually to have a plugin, a convention plugin, which was simply responsible for setting up build scans for all builds. So setting up the server that we push to, and I think that you would share the link to the server. It's a Gradle Enterprise server, which is actually public, so people can see everything that we build there. So set up the credentials so that only CI can actually push to the cache, etc., etc. So many different aspects, but this is already one kind of convention, like how do I publish a build scan? This is, a small amount of tasks that you have to do, configure everything, and you don't want to repeat that into all the different projects. So there is one plugin, a settings plugin in that category, which is actually responsible for doing that. So once we had that, the only thing we had to do is just to apply the plugin to different projects. That's it. And now all the projects push build scans. And that means that I can start modifying those build scripts and make sure that actually they do what they used to do, but not fully incremental. So get the data about what is different, what are the when you run a build twice in a row, make sure that everything is up to date. So all the traditional developer activity stuff that we do for Gradle builds. Yeah. So this is a really a first good example, I would say, of what a convention plugin
and a question for me, because I've never done this on that scale or many projects before. Usually you have one Gradle Enterprise plugin, and you have everything kind of in there with you got your tags, you got tagging, build this and that, build cat, all this stuff. So how did you? So you essentially. How did you mimic that without having to do 60 of the, or doing the 60 times essentially?
So it's just a plugin. So it's really a plugin which is purely internal. So what we do is just the plugin would configure what you have in general just in a build script. Like in a build script, you would have a Gradle Enterprise block. Well, it would apply the Gradle Enterprise plugin first. Then it would configure the Gradle Enterprise extension to set a server, then to set the tags that you're going to publish, then potentially have plugins to fetch the GitHub branch that you want to have in your scan, etc., etc. So this is something that you have in the settings script, but instead of having that in a settings script, this is now moved into a convention plugin. So we don't repeat ourselves. So it means that the only thing now that we have to do is apply a single plugin. And this guy is going to apply all the different plugins that we use. So Gradle Enterprise, I don't know, we have code quality plugins, etc., etc. So it is responsible for doing that. So the configuration is just there. And it means that if we have to change the configuration, we do it once in the plugin. And then the only thing that we have to do is to change the version of the plugin that we apply on the different projects.
Got it.
So, and maybe, and this is all automated. And maybe I should mention how we do that, like how we do the upgrades, because this is also something interesting in the way Micronaut does that. So we have another special project. So I talked about the Micronaut build projects, which is really the plugins, Gradle plugins there. But we have another one which is called Micronaut Project Template. And this one, as its name says, it's basically a template of what is a Micronaut project. So it contains build scripts, it contains sample modules, and it contains all our GitHub workflows, etc., etc. So this is really the template of what should be a Micronaut project if you create a new one. So it could be our team doing that, or it could be community just wanting to create a new module, I don't know, for supporting the new Kafka, whatever, right? So you want to support a new module, you just fork that project. And this project actually contains all the synchronization data that we want. And in particular, it's capable of handling the dependency upgrades. So we would set up, now we use Renovate. We used to use Dependabot for that, but typically we would use Renovate now. And every time we release a new version of the plugin, actually we get a Renovate pull request automatically to upgrade all the different projects. So
you can manage all your dependency upgrades on this thing as well. So when like Log4j situation happened, should have been fairly easy for you guys to kind of.
We could do that. We could do that. But yeah, for dependency management, we have a more complex system, I would say. Like we use the latest Gradle feature, which is called version catalogs. And we publish version catalogs for every project. We handle all the dependencies with that. And we also have a special kind of module, which is called a Micronaut BOM, which is for every project. So this is actually another kind of problem that we wanted to solve. Like it was the case before that you could release a Micronaut module, so not Micronaut core, but a Micronaut module, and that module would publish a BOM, so bill of material, the typical Maven BOM, And every single project was doing that in a custom way. Like it was basically copy and pasting some script which was in that template project. And it was error prone. It was difficult to actually make sure that all the dependencies you reference in that are actually published on Maven Central, etc., etc. So we figured out, hey, all those projects are doing the same. They're copying and pasting things, and they don't do validation. They don't guarantee that if we want to publish a BOM, then all the versions are going to be actually published on Central, etc. So how do we consolidate that into something which is usable by all projects? And this is what we do now. So we have modeled the different kind of modules that exist in a Micronaut project. So one is a Micronaut module, like a typical extension for Micronaut, but we also have this convention plugin for BOMs now. And the only thing that we have to do is just now in the different projects apply this BOM plugin, and that's it. And it does everything to publish the BOM, activate all those checks at publish time so that we don't make any mistake anymore. So that's really, really something that helps in terms of maintenance and making sure that we don't repeat the errors that we had in the past, like broken BOMs in Maven Central.
Nice. Thanks for sharing that. Well, one gentleman had a question. He mentioned he did a similar thing with the Gradle Conventions plugin for 14 microservices, and he said, but his build times went up. And for you guys, I know build time in general. I recall when we had our first conversation was a challenge because you had all these old build scripts and whatnot. And was I understanding it correctly that you weren't able to use caching well, and even incremental build cache wasn't working well? Let me tell us correct. A bit about that.
It was in a terrible situation, basically. So because of that old legacy of all build scripts coming from Grails, it was very difficult to actually figure out what was building, and you could run a build, run it again, and nothing was up to date, whatever. So really, the first step was to reduce as much as possible the size of all the independent project build scripts so that we have all the logic in a single place and fix all of those issues of up-to-date checking, caching, etc. So the responsibility of all those convention plugins is to do that. Like all the different projects that we have, they shouldn't have any build logic in there, mostly. They can have some in some special cases, but it's also put into some special scripts. Like it's not in the main build scripts. It's really plugins, local plugins, if you want. So move all that. And yeah, when we started, the build times were quite high because no up-to-date checking, no caching, no test distribution, whatever, blah. So it was super important to make that move so that we can have faster feedback. And there's one project which Sergio particularly likes, which is the Micronaut starter, so Micronaut launch, because this one has terrible build times. Like you can think of that as a giant test suite. So Micronaut launch is maybe you can share the link, but this is basically a web UI where you can actually bootstrap a Gradle project or a Maven project that uses Micronaut, and you select some features that you want to use. So say you want Micronaut data, GDBC. There's actually a feature for Gradle Enterprise, so you say, yeah, I want to support Gradle Enterprise, and it's going to generate a project for you. But you can imagine that all the different combinations of features have to be tested so that we generate build scripts which work, so that we make sure that you don't use two different features which are not compatible with each other. So the test matrix for that is huge. So we're talking in terms of days of testing. Like if you run the whole test suite on a local machine, it takes hours, really, literally.
I think it takes like an hour and a half locally for me.
No.
So this is a user asked a question related to this, which is exactly what Cedric said. How we ensure compatibility between all the artifacts. So we published, and there is another question also related about by Gabriel about using dependency automation tool. How we miss. So we in Micronaut we use semantic version and we try to be quite strict about it. So both core and the modules use semantic version. So what we do is whenever we get a transitive dependency update, if it's a patch update, and we know that the dependency is using semantic versioning, we will merge it. So patch versions of modules will include upgrades, patch dependency upgrades of transitive dependencies. But we will not merge a minor upgrade of a transitive dependency. We will merge the minor upgrade in the next minor of the module. And Micronaut Core, the bill of materials of Micronaut Core, will only update to next minors of modules in the next minor of Micronaut Core. So essentially what this gives users is we typically release patch versions every week, more or less, or every 10 days, something like that. So the users should know that they are not getting new features, but they're not getting any breaking changes either from Micronaut or for transitive dependencies. Or so the patch upgrade cycle should be just as easy of changing a versions for the users and sleep well. And for minors, they will get like new features of modules and Micronaut plus minor versions of transitive dependency, which sometimes contain new features. And we don't merge those depend about or renovate PRs automatically. There is manual intervention by someone in the team reviewing that PR and clicking the button. So it's often the case that we close something or we actually go and check the release notes for the thing being updated. And in terms of testing, is exactly what Cedric said, is we have two massive test suites. One is a starter and the other one is Micronaut guides. So guides are step-by-step tutorials, which have been improved in terms of build quality a lot in the past year. And what we actually do is we run the test suite of those, and they test not just Micronaut Core, but Micronaut Core plus some features. So we know that the features work together. And as Cedric was saying, we in the starter we run, and in guides we generate the project and we run a Gradle test or maybe verify. So it's not that we know that the thing compiles, that we know also that the application starts and the test pass, right? So we are quite confident that when we release a new version of Micronaut, if there is a module that is not working, it's not because it's probably because we are lacking a test for that. But we test also so Micronaut right now supports Java 8, Java 11, and Java 17. So we test with the matrix of the 3 JDKs. A starter also like generate GraalVM native images of our CLI. So starter is quite interesting because it's a project that actually is built with Micronaut, because the starter was released when Micronaut was already there. So we actually use Micronaut to build a starter. And the starter generates both the command line application and the web application. And both the command line application and the web application that shares some logic. So yeah, it's those two builds plus core are probably the biggest ones that we have. Core actually is really nice now. It's really optimized to run locally really fast. But the starter and guides are still a bit slower because they are like really a safety net for us.
Yep, they're still slow, but we are making good progress on that. And again, this is thanks to those scripts that we share. Like because the initial state was bad, actually once we fixed the convention plugins and that all the projects use that instead of their custom logic, what we could do very easily is say roll out the build cache. And the way we do that is just we change the Micronaut build so that now it's active. And we release a new version, we change the version on all the different projects, and they all have the build cache enabled. And that's really massive change. Like if you're today a Micronaut contributor, or just you want to check out any project from Micronaut, you clone that, you run the build, and if you don't change anything, you should get everything from the cache, like everything from the remote cache from this Gradle Enterprise server. So this is available not just for us core developers. It is also available for contributors. So this is a massive improvement for the whole community.
And would you say, Cedric, this was one of the bigger productivity wins when you were able to kind of analyze what's slowing things down with Gradle Enterprise and roll out this build cache? I mean, how much faster did a PR build get, for example, on that large project, that large project that Sergio was talking
about? So it depends on what you change now, but it used to be several hours, but now it can run really, really fast. I would take the Micronaut core example first, because this is a more classic Java project. And there we started from basically zero reuse to run everything in seconds. So that's a massive improvement. And for guides and for this starter launch project, what is going to make the biggest difference is the new feature that we enrolled last week, which is the test selection stuff. So this one is actually super interesting, because Micronaut guides and Micronaut starter are the typical use case where actually what happens is that you just upgrade one dependency. And what is the biggest chance that you break something if you do that? And actually figuring out, just by hand is super difficult. But with the build history in Gradle Enterprise, the test selection is able to do that for us. So it means that we change the dependency, and then it would figure out by itself that actually it should run those tests rather than those ones, to make sure that actually the upgrades doesn't break anything. And the benefits that we're going to see if once, well, actually it's still learning, but the initial state that we have and the dashboard tells us that we're going to save really days of build time, and for our feedback cycle, this is going to be huge. Like I think I checked yesterday, and just for the last couple of weeks, we already saved more than 60 days of machine time. So that's massive, right?
So the starter for us is like a project where we test things such as, does a Micronaut application with the Azure plugin works? And if you are like adding something which is completely unrelated to that, right? If you are adding something like a new feature because we have a new module, we were essentially rerunning all those tests, right? And it was not because it was correct from the build point of view, because something has changed in a core module, which was a dependency, so we had to rerun the test suite, right? Even if we know that all those tests, they are going to pass, right? So there was nothing, that change was completely unrelated. So for us, I think the start is when we are going to really see massive improvements with basic text selection, because it's essentially where all of our build time was going to tests. So the build time was completely spent on tests, and most of the times the tests were completely, because they were testing many different features, so it was completely isolated from the change that just happened in the PR. So I am really optimistic about that, and as someone who works often in a starter, that's a really productivity drain, because it's not just the build time, it's that GitHub Actions and every other CI tool we were using I think when we started Micronaut, or I don't know if in Micronaut, we are using Travis. So the problem with CI tools is that if the build is too slow, things start to queue. So it's not that you have to wait for your build to pass, is you have to wait for the whole queue. So I think that's for us, it's going to be huge in terms of PRs not being stacked on the queue. So that's going to be great because it's going to snowball the whole effect into like the ability to like work on PRs, merge PR, give feedback, do changes to PRs, things like that.
Because there weren't many options before. Like, what could you do to solve that kind of problem? Basically the only options that you had was rewrite the project so that all the combinations are actually in different projects, like actual Gradle projects. Like you create different submodules and actually you change in that module, that version, and then you could only re-execute the test in that module. But that would be extremely painful to maintain. Like you would have to create hundreds of different modules. The other option that was used before is actually to have some smart, by that I mean manual, way to actually execute sub-builds. Like you have workflows which actually execute sub-tests, like -- test, and then you tell, okay, it's just a subset of the tests, and then you pray that the failing build is going to fail first. And the problem is that you can also reach the quotas. Like with GitHub, you have all those parallel builds, but they would not actually run in parallel if you have too many of them. So you cannot really split into too many different workflows, parallel workflows. So this test selection stuff is really huge because basically we don't have to do anything. We just remove all our custom logic to use -- test, and that's it.
And for our audience, right, Cedric is referring to the new Gradle Enterprise product extension called Predictive Test Selection. It was initially a study that came out of Google and Facebook, and our analytics team productized it and was released. And Justin posted a link to, so you could check out Micronaut Framework's test selection results, right, directly with that link. And Justin, when you have a moment, maybe put a link to what predictive test selection actually is for the audience as well. And what else would as we're wrapping up? Any other productivity wins with Gradle Enterprise that you want to share? What anything interesting you found from the data? Right, we talked about build cache, we talked about test selection. Was there anything interesting from the data that you found? You have all these developers all over the world, and now sure. 100 projects, right? And there's only a few of you kind of working on this thing, right? That are doing the productivity work, right?
Yeah. So I didn't mention that, but maybe we should start with build scans themselves, because actually what you can do is that you can have. When you run the build, a regular Gradle build, or you can do that with Maven. You do that with -- scan, and then publish this build scan, which gives you all the insight about what happened in the build. And typically, I don't know if I built something locally and it fails, and I don't know why. What you had to do before is just to copy and paste that stack trace and put that into Gitter or Slack or whatever, and share that with Sergio, and he would tell me, hey, that's great, but actually you didn't paste the full stack trace. But he answered like an hour after I asked the question, and now I lost the stack trace and I started on something else, and we lost the data. We cannot debug that like with scans, actually, because everything is tracked, and everything that happens in a build, it can be a local build or it can be a CI, creates a build scan that we can come back later to, and then we can share just the link to that scan, and we get insight about the failures, test failures. We get insight about the dependency graphs, etc., etc. So this is a really good collaboration tool in this context of this distributed team.
Yeah, I wanted to say, so exactly what just Cedric said is we are seeing so we have kind of an internal chat room for the core developers, and we see often, for example, we saw yesterday a colleague sharing that he was finding a flaky test that was not there before, and he essentially shared the link to the build scan. And one thing that seems minor but I used all the time is when we run builds on CI, since at the end of the build, the link to the build scan is published, for me, often the quickest way to see which test fail is to essentially click there and go in the test UI or build scan, which is a much nicer UI than try to find the test failure in an infinite stack trace in GitHub Actions. So I use that a lot, like going to the build scan and go to the test navigation in the sidebar and just filter there the failed test, because you can see like the standard output there. So I do that even locally. So instead of like opening the local JUnit reports, sometimes I go there directly to the build scan. So that's something that is quite useful for us in terms of being able to debug CI failures.
Awesome. Thanks for sharing that, Sergio. And anything you all want to add before we go to questions? Any other productivity wins that were worth noting?
We didn't actually mention the user plugins because we already we talked mostly about how Micronaut is built itself, but we kind of want to apply the same techniques for users. Like the idea would be to minimize the size of their own build scripts typically. So if they apply the Micronaut plugin, they would get this DSL to configure, and we would model all the different kind of Micronaut applications that you have. So I don't know, just a Lambda, whatever, would be modeled as a DSL block, so that you don't have to know about the dependencies that you need to add to support that, etc., etc. So we're not quite there yet. There are still some manual things that you have to do, but we are trying to apply the same logic to the build plugins.
We do a little bit of logic. So if you started with Micronaut 1 and you should check a build of Micronaut right now, the build is more succinct right now. As Cedric was saying, for example, we have a plugin extension which essentially allows you to select the runtime. You can say, I am running on Netty or I am running on Undertow, and the Gradle plugin will add you those dependencies for you automatically. So you don't have so our dependencies block right now is much smaller, and I think we can still improve on that. But we kind of, we have our Gradle plugin, for example, makes really easy for users to generate things such as a GraalVM native image, which was really tedious in first versions of Micronaut. It's really easy also to generate like a container image as well. So we have kind of, and also to distribute those to container registries. So we already have, I think, some nice features on the Gradle plugin that are compelling to users, like a Gradle task to essentially publish to a container registry. But yeah, we are still working on that. And one thing that I would like for us to do is have like plugins for Micronaut library authors so that they can publish their own open source or internal Micronaut libraries in their companies. And we have, for sure, a lot of margin of improvement there, and we will get there.
Thanks for sharing that. And let's take some questions.
Yeah, thanks. So you guys did such a great job, actually, kind of keeping on top of that Q&A widget and answering the questions sort of contextually. So I really appreciate that. Makes my job easier. Hadi is asking if you could elaborate a little bit more on the bill of materials setup. Specifically, what is the process to bump up a version? I know you kind of mentioned a little bit about semantic versioning there. Where are the versions? Probably held in a separate repository. If you could talk just a little bit about the mechanics behind that.
Yeah, I'm just going to paste a link in the chat. As Cedric was saying, we use version catalogs. So this is an example from the first module that I took. The gRPC module defines the version of gRPC there. So we will get a renovate PR there. And the BOM module, which is actually a huge improvement. If you saw our BOM module initially, our BOM build script to what it is now. So this is just the build script for the gRPC BOM, which is just applying the convention plugin. And before it was really prone to error, and I had myself done errors. For example, I remember we did an error in the Micronaut views where we broke the BOM, and it was published in a completely incorrect BOM. So anything that we can do to avoid errors that force us to have to release a new version, they are always welcome additions. So then Micronaut Core will contain the gRPC version number. So let me just show you that. I hope that's more or less what you were asking.
So I think we forgot to mention one thing also, which is also an interesting aspect of the convention plugin. So I think the question was also about how we deal with version numbers and semantic versioning. And one thing that we added recently is binary checks, like binary breaking change. So whenever you build, whenever you create a pull request, actually we trigger binary breaking change tests, and you get a report if you actually break the binary compatibility. And no, again, all those projects got that for free, just because we added that to Micronaut Build, we bumped the version of the plugin, and now all the different projects just benefited from that. So now every time someone creates a pull request, we know if there's actually a breaking change, and if there is, they have to explicitly accept the regression, say it's a bug fix, you have no choice, you have to break the binary compatibility, too bad. Well, okay, but then you're going to modify that file, which is going to say, okay, I accept this regression with this reason. And if it's not the case, then basically it means for the developer that they have to bump the version to major.
That's huge for us because in terms of allowing us to improve the PR feedback cycle, because things such as adding a new parameter to a constructor that you think is nothing, so it was really easy for users to submit a PR, which we love, that they submit PRs, but that the feedback loop cycle was that you have to add another constructor, and this with add inject, deprecate the old constructor. So they will give, the build will fail basically right now. And they will get like this is failing, and it opens an HTML page and it tells it fails because this breaks binary compatibility. So it's great for users. It's great for the module maintainers because it's easy to miss a binary compatibility change if the build doesn't fail, right? So anything that we can do to essentially reduce the human error in PRs is great because we have many PRs. So yeah, that was huge. That's probably a month ago or 2 months ago, but I think it's already has proven already really useful. Really happy. We are going to have to use it a lot when we release Micronaut 4. We thought the removal of the deprecations, but really happy that we have that.